This experiment begins with powdered copper on the left, powdered zinc on the right. You can see they're different colors. These are metals that have been ground into a very fine powder. I'm going to mix them, and then we're going to do an experiment to analyze the mixture. So now the powders have been mixed. You can still see traces of copper color in the zinc. But certainly it would be very difficult to separate these with a pair of tweezers. So our goal is to analyze the mixture. What percent of the mixture is zinc? What percent of the mixture is copper? We can do that by reacting the mixture with this hydrochloric acid. Now, last week we learned that hydrochloric acid can react with zinc, but copper metal is resistant to reaction with HCl. So if we run a reaction where we put the mixture with the acid, only the zinc will react. I'm going to fold up my zinc and copper mixture into a kind of envelope. The reason for this will become clear later. 20 milliliters of 6 molar acid into the flask. I'll run the reaction in the flask, but I'm going to use a stopper with a plastic tube connected to transfer the gas in a way that I can measure the volume accurately. Here I have a tub about half filled with water. Here I have a graduated cylinder filled to the brim with water. I'm going to try to invert the cylinder without losing any water. Lost a little bit of water, got a few bubbles here. Alright, so here's my cylinder, mostly filled with water. I probably have about 5 milliliters of air at the top. I'll use that as an estimate in my calculations. I will now put the end of this tube into the cylinder from below. Now I'm ready to start the reaction and have the gas be carried over in a way that I can measure it. This is my package of zinc-copper mixture. The reason for the package is I don't want the reaction to start until I am ready. So there we go. Put the stopper on the top and shake the... Alright, so now I've shaken the package into the acid so that the acid reaches the metal within. You can see the bubbles are being collected in the graduated cylinder. The bubbles only come from the reaction of zinc. I've shaken the flask considerably. The reaction rate is pretty fast now. You can see the gas bubbles are moving over quickly. The volume can be measured. So I can read the lines on the graduated cylinder and get an accurate measurement of the volume of gas collected. About 8 minutes have gone by. You can see the reaction rate is slowing. Same reasons as last time. The acid molarity is being depleted, and the surface area of the zinc that remains is also diminished. It's been about 30 minutes. Now the reaction has completed. Over here we can read the volume of gas collected. It's very close to 300 milliliters. So I think it's about 305 if we read the bottom of the meniscus. I will estimate that we had 5 milliliters of air in the cylinder to begin with, so 300 milliliters of gas has been produced in the reaction. That's all we'll need to calculate how much zinc was in the mixture. These are the contents of the flask after the reaction is complete. What we're left with is pure copper. All the zinc has dissolved.